Hello Internet! Today we're going to talk about Dockerizing Python, as in wrapping a Python application within a container. We'll start with a keep it simple stupid solution, and we will build up from there to a fully fledged container that's going to have a lot of bells and whistles, and is going to be fully packed with all the optimizations that you can think of, and maybe even more. And stay tuned to see all of that. For all of you who are impatient, this is going to be our final Dockerfile. It's going to contain a lot of performance optimizations and caching strategies, and a lot of interesting things that we've done to make this compact, powerful, expressive, and actually maintainable. So if you're curious, let's dive in together and actually start building from quite of scratch and building up the complexity and reaching this final product. Okay, this is our application. It's a very simple server. It's going to be served with gUnicorn and with Fast API. Each variant that we have, it's going to serve its own JSON payload. And we just have our own Python requirements, which is just pinning the version numbers of each dependency that we have in our project. And we have a simple configuration file for our production server, which is Gunicorn or gUnicorn. So this is our application. It's not going to grow in complexity, and we're just gonna worry more about actually packaging this application, less so about the actual server itself. So this is our the simplest Docker file that we can start with. We just use the Python-based image. We create a working directory, copy all of our source files, and we pip install our requirements, and we start gUnicorn. As we said, this is our production server. Once we've done that, we do need to set up a little bit more stuff around our Dockerfile to make sure that we've got like our development environment working correctly. So we've got our dockerignore file, which basically tells Docker what not to copy into our file system within the container. And we've got our docker compose, which is a utility file that we've got. So we'll have a very nice experience while developing this locally. Okay, so this is going to be now a short demo of the Docker compose. So if we cd into step 1, which is our keep it simple Docker file, and we just write docker compose up -- build, that's going to rebuild our Docker file from scratch right now. And we're going to run that. That's going to be run super quickly. And once we've got everything installed, it's going to actually bind our server to the port, and we can actually reach this server, and we've got our variant, which is the keep it simple requirements variant. Okay, so this image is actually already production ready. Our keep it simple stupid solution is actually just working, and this would actually serve traffic securely, and this would work. I mean, securely as in you need to secure a server, but that's your problem, not the Docker files. So what did we get right here? We got simplicity right. This is as simple as it can get, and that means that it does not have a lot of mental overload on you, the developer. But there are a lot of things that are kind of wrong with this implementation, which is our builds are not reproducible because we're just pip installing our root dependencies. We're not locking anything. Every time we build a server, we are busting the cache, and that means that we need to actually rebuild every layer every time, and that's a waste of storage space usually, and also that means that your builds will be slow. And our app right now is basically just a Python script that happens to be on the path of Python, but we do want maybe for that to be a little bit more, let's call that package-like, that's like installed on our interpreter. So we're gonna handle all of that and a lot more in the next steps. So we're all civilized people. Let's use the package manager. In this tutorial, we are using Poetry as our package manager because, well, it is a solid package manager. It is really mature. It will provide us with a lot of features that are needed for us to have like a very smooth working flow around actually locking dependencies and collaborating with other people, which is very important. First of all, we've got 2 new files now. PyProject.toml defines our structure, our scaffolding for the project, and Poetry lock defines our exact package versions that we use, and that is going to be committed into our Git repository or whatever VCS solution that you've got. And that means that when we're collaborating with people or pushing this to be built somewhere else, everyone is going to use the same exact versions of each package whenever they run Poetry install. To use Poetry within our image, we do need to do some updates. So first of all, we need to install Poetry itself. We will do that with pip install Poetry. Other than that, we copy our source files just as before. Then we run Poetry install. Poetry install would actually create a virtual environment within our container and would install all of the dependencies there. That keeps the Poetry dependencies and the project dependencies separate, which is a good thing. To actually start our server, we do need to update our command to use Poetry run before everything, because that means that we're now using Poetry to dispatch the right virtual environment. Just like the previous container, this one is also production ready. But we've fixed some things. So we are guaranteed to install the same dependencies that we've got on our dev machines. Our app is now a Python package because we are getting that essentially for free from Poetry. And we do have a few smaller issues that have emerged from using Poetry. So first of all, Poetry itself, we're just pip installing it without any version pinning, and that may introduce breaking changes later. So keep that in mind. And Poetry created a virtual environment. If possible, we'd like to actually get rid of Poetry's virtual environment very soon. So let's address some of these basic issues. So first of all, as we've said, let's pin Poetry's version. The other things that we can actually fix is first copying only the PyProject toml and the Poetry log files, running Poetry install without installing our own package, copying the rest of the files, and then running Poetry install again. This would solve another issue that we've got with the keep it simple variant, which is that, as we've said, we were busting the cache a lot of times because every single change in our files would actually trigger a full rebuild. Right now, when we are changing dependencies, it does require to run Poetry install again. But when we're changing our source file and we're just copying our code, that would not actually affect the installation of our dependencies, which is going to be very useful because dependencies don't change very quickly, but source files do. Let's take like a high-level status. So we've got our stronger reproducibility guarantees from Poetry and from pinning Poetry's version itself. We're now utilizing our layer cache. We do still have some issues around our actual server, which is, first of all, it's still running in a virtual environment within the container, which is basically unnecessary. And Python is misconfigured to be friendly to our container host. And we're still writing our code in like kind of small app mode. Let's actually try to address these issues a little bit more thoroughly. We can make some non-trivial updates to our Dockerfile, which is going to be like the biggest change that you're going to see in this video. First of all, we're going to use Docker's multi-stage builds to split Poetry into its own separate stage. That means that we are now installing Poetry with it in its own basically container. We're going to copy over the same dependencies just as before. Instead of running Poetry install, we use Poetry export to generate our requirements txt file. This txt file is now basically just a derivative of the actual Poetry log and PyProject toml files, and it is generated on request before our build. This is going to be useful because now we can copy that into the second stage, where we all we need to do is basically just copy it from the previous stage and then run pip install, and then we don't need even Poetry within our actual production image. Other than that, we are using some environment variables to configure our Python interpreter to play nicely with the container host. We've got our Python don't write bytecode environment variable. This configures Python to not write .pyc files onto disk. That is going to be useful because when we're booting, we don't need to write anything to this because this is going to live as a stateless server somewhere, and writing to disk is going to just waste our resources. Secondly, we've got Python unbuffered. That is going to tell Python to not buffer any output that needs to go to standard out or standard error. And that is going to shift this labor onto our container host to actually buffer things. That is going to be useful because we don't want to double buffer anything here, because we're running in a virtualized environment and we're gonna just let our host handle the load. Additionally, we've got our Python fault handler, which dumps a stack trace onto standard out on every, let's call that a fatal signal, either sig_v or sig abort. Basically, that's going to help us debug if we crash, and that's going to just help us see what was the last thing that happened before we actually got our error. And we've got like the pip disable pip version check. That's just going to silence pip from saying that it's not up to date. This was quite a big update, so let's just summarize that up quickly and then move on to fixing more problems. So we've got multi-stage builds to separate our poetry export and our actual installing of the dependencies. And we have configured our Python interpreter to actually play nicely with the container host. Another side note, do not use Python optimize. This is another environment variable that people are sometimes tempted to use, but some packages actually rely on the bytecode not being optimized. Be aware of that. And I recommend just not doing that. It's just not going to save you a lot of time actually during runtime when you're running with optimized bytecode. That was the good stuff in the updates. What problems do we still have here? So first of all, we still have our small app mode, and our Dockerfile is quite complex right now. So let's move onwards to simulating a larger project. And once we've done that, we're gonna see where we land and move on from there. We've added some tests. We've added a source directory with now it can host multiple root packages within that directory. We've got PyTest, we've got coverage, we've got rough, we've got MyPy. And we don't want all of that tooling within our container because we don't use that while running the server. We just want that during development. We just need the source code. So let's update our dockerignore to actually ignore everything. And then we selectively add back only what we need. Now, copy ... on the Dockerfile remains unchanged, but it has a different meaning because we've updated our dockerignore file. So to summarize up all the things that we did. So first of all, this Dockerfile is actually already fully featured. It has everything that you would need for a very mature server with a lot of dev tooling, with a lot of tests, with a lot of multiple internal packages. And there you have a reference for adding an optional dependencies, ignoring required dependencies. And we are not busting the cache on every code change, only on actual dependency changes. And that would get you very far into actually serving traffic. But we do have some extra things that we can do that would actually make our lives a lot easier in the long run. We're going to talk about compiling dependencies. We're going to talk about caching everything. And we're going to talk about shifting some of that complexity away from the Dockerfile and onto pre-commit hooks. That's going to actually cancel out the first stage, way more easy to maintain. First of all, let's talk about compiling dependencies. So each sane project usually has a database that it needs to connect to. Some databases require some database drivers require that you actually compile the packages. That's usually not an issue. If we're actually just using the base Python image, then everything is just going to be fine. But if you're going to use a -slim variant of your image, then that's going to hurt you because the -slim version does not ship with a working compiler. So in order to actually address that, you would need to apt-get install whatever it is that you need to actually compile this. In this example, we're going to use psychopg and actually compile that from source. But I would recommend staying away from slim images, or if you if you prefer actually installing only what you need, then go ahead, do that. Okay, as a warning, please do not use or at least try to avoid using -alpine. It has the muscle libc implementation, which has slight API differences. And that means that you might install some Python packages with pre-built binaries or compile them yourselves, and you'd fight your either compiler or runtime issues with ABI incompatibilities. So beware, I do not recommend using -alpine. Okay, so that was compiling dependencies. Now let's talk about speeding up our builds even more. So we're going to tap into Docker's build cache as hard as we can, and we're going to try to pre-compile all the pure Python files into bytecode. So we'll have everything preloaded, and then once the container boots up, it just needs to read the bytecode directly off of disk and does not need to recompile your source files back into actual bytecode. Okay, so we maxed out our speed and our boot time, and at the cost of a little bit of complexity. Now let's talk about moving some of that poetry complexity away from our Dockerfile, and that is with running poetry export externally and committing our generated file into Git. Once we've done that, we do have a very simple Dockerfile. We've got rid of the multi-stage stuff. So all we've got is our base image, which uses the environment variables, copies our generated requirements file. We still require our hashes, and then we pip install our root package, and that's it. We can run our production server just as we did before. That has now a cost, because we do need to run our own poetry export, which is kind of annoying. So in order to not have like a split brain state of one source of truth thing, we'd like to actually generate our poetry export from our poetry log file every time it changes. So for that, we're going to use pre-commit hooks. This is our hook definition. It's going to contain a very, we're just going to use poetry's own pre-commit hook that has like the poetry export hook itself. That's going to work very fine. And every time now that you are updating your dependencies, pre-commit is going to update your requirements file and drop and going to stop you from committing an out of sync file. So that's going to be very useful for keeping the requirements file up to date with our poetry log. And that means that we still have a single source of truth, which is our PyProject TOML and poetry log files. And this requirements file is now a materialized view of our log file. And that is going to keep the complexity out of a Dockerfile. It does mean that we are now using pre-commit. So keep in mind, you can pick and choose whichever you prefer. Don't forget to add that requirements file onto your Dockerfile, dockerignore file, because, well, you're going to need it, and it's going to be airing out if you don't do that otherwise. We covered a lot of stuff, so let's actually bring it all the way from our keep it simple back into our fully featured Dockerfile, and then we're gonna see the fruits of our labor. So first of all, we started with a requirements file that's very, very, very simple. As we've said, we just pinned our 3 main dependencies, and that's it. We pip install them. Then we added poetry to actually manage our dependencies when we've got our dependency groups for production and not production. Then we split our poetry onto the export stage, and then we used pip to only install from our generated requirement stage. We've handled a growing project with a lot of dev dependencies and a lot of dependency groups. We've got our Docker build working also with packages that require a working compiler. We cached everything aggressively, and we got away without using multi-stage builds in the end, if you choose to run your poetry export outside of your Docker build. And thus we deserve to actually reap the fruits of our labor, and this is back to our final gold-plated Dockerfile that has a lot of DX improvements and a lot of speed-ups and a lot of caching, and this should make us very, very happy. And that's it. Thank you all for watching. I'll put links in the description for the source repo with all of these steps and with all of these demos. You can clone that, run that yourself, and hopefully you'll have a working, production-ready Docker image from this tutorial. See you all in the next video. Bye-bye.